All right. Well, what I want to do today is, like every time, go over the homework assignments from this week from the forum. And then we're going to talk about dictionaries. And dictionaries are super, super cool and super important as well. They're the most important data structure in all of Python. I think we've now gained enough experience with other data structures. We can see sort of good, bad differences with them. But dictionaries are all good. They're great. So I am going to, here, I'll move this over. Start sharing my screen. There we go. Step one. Boom. We can do that and share. Okay, and now let's just move all these other things over to other windows. Why is it not? Oh, that's funny. Okay. That's sort of weird. It's like floating in the middle of my screen now. I just got a new computer, so it's kind of weird to see that. Okay, fine. All right. What I want to do, I wanted to copy. I'm not sure if I see the chat. That's the only thing. Chat. Oh, yeah, there it is. Oh, I don't know why. Okay. Oh, I see. I was doing Q&A. I always get mixed up between Q&A and chat. Why would I get mixed up between two such things, right? So obviously different. And let's see if I can like move. Oh, I can move. Oh, very cool. I can move the window. Okay. So I'm going to put these in here now. Let's do this. Let's see if I can do this here. I'm going to do dot and dot and dot. I'm going to make this into a markdown. All right. Better. Like could be worse. And now, wait, let's see. I think this will work. No, it did not. Okay, let's do this again. Okay, let's just like put these. Okay, better. Could be worse, I guess. All right, so we're gonna go through the exercises now. And people, obviously, if you have questions, let me know. Let me edit this. Here we go. Just started doing this like in the last week or two, like actually using the markdown capabilities in Jupyter. And it's on the one hand great. On the other hand, everyone loves markdown. I'm not so good at it. So sorry if I messed up there. Okay. So we previously wrote a program that took a single word from the user and translates it into Pig Latin. And just to remind you what that program looks like, I can say here, like word equals input, enter a word. I'll even do a strip on here to get rid of any white space on either side. And then I can say for one, well, actually, no, I can just say if word 0 in ARU, right? So if the word starts with a vowel, then we will print out, we'll say here, do an F string, I guess, F string of, we'll say word, and we'll say here, way. Else we'll say print of, and then it's gonna be a little more complex. It's gonna be word 1 until the end, followed by word 0, followed by AY. And we can try this out. So if I say like, you know, elephant way, very good. And if I say here table, tay, we are doing great, or rate gay, I guess. All right, but this is not what I wanted, right? This is what we had already that worked with one word. So how can we get this to work with a whole sentence? Well, we're still gonna ask the user to enter some text, but now we're gonna say enter a sentence, right? But as far as Python's concerned, there's no difference. We said enter a sentence, we said enter a word. Really what we're gonna get back from the user is a string. So let's store that string, not in Word, let's store that string in something we'll call sentence. Now, as far as Python is concerned, this line has remained the same. We've changed the variable name. We've changed the prompt that we're giving the user. But we're asking for a string, we're getting a string, end of story. But we as users and we as programmers now need to look at it a little differently. So I have this string. How is sentence different from word? Well, sentence contains multiple words, and they are separated with white space. So what I could do is I could say something like this. I could say all words equals sentence.split. And remember that sentence.split, split is this method that returns a list of strings based on a string, breaking it at white space. So wherever there's one or more space characters, we're now going to get back a list. Well, we're going to get a new string. That's all going to be in all words. And then we can use our loop. And now we can say something like this. I can say if, oh, not if, for one, let's just say word in all words. There we go. Not quite done, but pretty close. What am I doing here? I'm taking the string sentence, I'm breaking it into words, and then I'm going through each word and I'm going to print it out, translating to Pig Latin. So if I now say this is a test, the good news is that it's now all printed out, right? It's printed out one word at a time. The bad news is that it's printed out on separate lines. What I would like to see, and maybe this is like being a little tough here, what I'd like to see is all the words on the same line. So how can I do that? Well, once again, lists can come to my rescue. What I can do here is I can say something like output equals a list. And then every time I translate a word, I'm not going to print it. I'm going to add it or append it to my list. And we'll output append to this. Now what do I have? If I say here print output, it's going to look a little funny, but it'll almost work. This is a test. And you can see that we have a list of strings. A list of strings, each one of which is a translated word. So how could I turn that into a nicely formatted sentence? I can say space.join, join of output. And now if I say this is a test, look at that. Now you can see here, we have lots of these sorts of things that we do all the time in programming, especially in Python. We break things apart, put them together, break things apart, put them together. So we take the sentence, break it into words. We then start with output, an empty list, we build it up. We build it up to have a bunch of things, and then we join it together. And this is why join and split are so frequently used, because they're so useful, because they really allow us to play with input that we got from the user, from networks, from files, very, very easily. Let's make this a little tighter, just a little bit. So I'm going to copy this code. And what I can do is actually, I can say this. I can say forward in sentence.split. I don't need to create a new variable because the thing I get back from sentence.split is a list. Can I do a for loop on a list? You betcha I can. So this is a little more Pythonic, I'd say. But it also is a little harder to debug, right? Because you're not breaking things apart. So at first, it's often easier to do things on multiple lines, print out what you've got, examine it, and then when you have it all together, then what you can do is you can, you can do it to this sort of format. Questions or comments about any of this? All right. If there are, obviously, you can just put them in the chat, and we'll take a look at next. Next, we're going to ask the user. There's more fun with split and join. And by the way, people all the time in my courses, and me too sometimes, make the mistake of strip versus split. Strip and split are very different. They just sound kind of the same. So strip removes white space from the edges of a string and returns a new string. Split returns a list of strings based on a string. Oh, someone asked, Ronnie asked, can we put the split in the first line of the input? So we can, if we really want to go wild, we could totally do that. We could say here, for example, input enter a sentence, then I could just say like, we can say here, words, all words equals dot split, right? And then I can just say in all words. That'll totally work. Absolutely. Now, if you really, really, really want to go crazy, and who doesn't? You could even combine this all together. Like technically there would be no problem with it. You could say forward in input enter a sentence dot split, but like then you won't have any friends. So don't do that. At a certain point, you really want to remember at the end of the day, you're writing code for yourself and you're writing code for the people who are working with you. And so you want to make the code readable, understandable. And this kind of, oh, I can stick lots of things together into the same line feels really great. You feel like an incredible sense of accomplishment that you've done so much in so little code, but then you come back 6 months later and you have no idea what you wrote. The Perl programming language was very famous for a long time. I actually spent many years using Perl. It sort of grew up parallel to Python. And one of, there was this almost contest, not even almost, there was a contest for many years called Perl Golf, where you would get a programming assignment and you would win if you could do it in fewer characters. And Perl was famous for having all these shortcuts you could use that made the code completely unreadable, but very powerful. Okay, so now we're gonna ask the user to enter several words separated by white space, print those words separated by star characters. So what are we gonna do here? We're gonna say here s equals input, enter a sentence. And we'll even do a strip here, why not? And what I wanna do is, so if I print s, so this is a test, it prints out my sentence. So far, so good. What we want to do, though, is we want to turn all white space into stars. So once again, I'm going to have to do the breaking down and the putting together. So I'm going to first break it down. I'm going to do it in several lines, then show you what we do in one line. So I'm going to say here, for example, words equals s split. And words is, of course, now going to be a list of strings. How do we know that? Because split always returns a list of strings. And then what do I want to do? I want to join those strings together with a star. So I can say star.join of words, and I just print that out. Oops, extra parentheses then. So if I say this is a test, sure enough, that works just fine. So here I've gotten the input, I've used split on it, And this splits on all white space. So even if my input is this, space, 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 is space, space, a, space, test, I'm still only going to get 1 star per white space. That's the advantage of using split here with no argument, as opposed to, say, splitting on space, literal space, or I think someone in the forum was talking about using the replace method. And that would work if you have individual strings, but it's not going to work so well if you have multiple white space there. So how can we make this a little tighter and a little smaller? Well, I can put it all into one line, not all of it, but a bunch of it. I can say here, print star join of words dot split. This is a test. And sure enough, oh no, it didn't actually work that well. What did I do here? List is no, oh wait, hold on a second. Oh, because I used words, haha, there we go. This is a better test. Ha, much better indeed. Because what am I doing here? I'm getting the string. And then we have this whole mess of functions. We have the print function, and its argument includes the join function. Its argument includes the split function, the split method. So we always start at the inside. So we're first going to run s.split. That's going to return a list. We pass that list to join. That's going to return a string. We pass the string to print. We get it printed out, and we're done. And that sort of step-by-step thinking is really important when you're doing programming. You have to be able to sort of, as Papert used to say, Seymour Papert, who started children programming in the 1970s with the Logo language, he would say you have to play computer, sort of reason out what the computer is doing step by step. And programmers do this all the time. Now, the problem is that our programs are often so incredibly complex that we think we're reasoning about it, but we're not paying attention to something that's actually going on. And that's where a lot of bugs come from. So they're bugs, they're problems with the code, but it's it's good intentions. We just didn't foresee things well enough. Okay, any questions about this? And then we'll go on to one last thing, and then dictionaries. Okay. And of course, keep the questions coming. Do not hesitate. All right, next up. Ask the user to enter numbers separated by spaces on a single line. So already I'm going to say numbers equals input, enter numbers separated by spaces. I'll even do a split here. I'm just going to turn that into a list right away. Now we know that numbers is actually going to be what? A list of strings. It's not a list of integers. So it's a list of strings. And I'm going to then append each number to one of 2 lists, either evens or odds. So I'm going to need 2 lists. I'm going to need evens as an empty list and odds as an empty list. So now what? So now we're going to say this. Now I'm going to go through each number that we got here, numbers, and we're going to say, is it even or is it odd? So I'm going to go through, I'm going to say here, for one number in numbers. And we have to check if it's even or odd, but wait, is it even a number? No, it's a string. What if we can't turn it into a string? Bad news. So I'm going to say here, if not one number is digit, print, let's do one number is not numeric, ignoring. And I'll do a continue here. Continue, remember, means go back to the top of the loop, go back to the top of the for loop, and ask for the next iteration, ask for the next element from numbers. So if we get past that point, we know that we have something that can be turned into an integer. So now I'm going to say here, one number equals int of one number. Great, now I have as an integer. And then I can do a test on it. And the test for even and odd is to do the modulus, is to divide it by 2 and get the remainder. And then the remainder, if it's 0 or 1, will tell us whether it's even or odd. So if one number modulo 2 equals 0, then we'll say evens append one number. Else odds append one number. And we're gonna, I don't know exactly, I don't remember what the mathematics are of it, but we're gonna say here that 0 is even for argument's sake, otherwise bad news. I can't remember for the life of me if it's really considered even or odd, but shh, don't tell my math teachers. All right, and then what we want to do, then we want to just print out our lists, I guess. So I'm going to say, oh, I guess we want to print the even numbers 1 per line with number characters. Okay, so what we're going to then need to do, well, watch this. Let's first start here, and then we're going to do more. So I'm going to say here, 10, 11, 12, A, B, C, D, 13, 1A, 14, 15. Okay, ABCD is not numeric, 1A is not numeric, ignoring otherwise evens. We got the even numbers, odds, we got the odd numbers. Big win. But now we actually want to print them. So we want to print the even numbers, 1 per line, with \n characters between them. Now, of course, I could do a for loop here. I could do a for one number in numbers, blah, 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 blah. But really, another way to do it, and we're not going to talk about a complex thing called list comprehensions, what I can do is go through the list element by element and turn its things into strings. I can even do this originally. I can say append stir of one number. Now, why would I do this? So now if I say 10, 11, 12, A, B, C, D, 1A, 15, 16, 17, 1 A, B, C, D is not, 1A is not. Evens, now look at this, evens is a list of strings. Odds is a list of strings. Why would I do that? Because now I can say print \n join of evens and print \n join of odds. Oops, \n join of odds. Now what happened here? Print, as far as it's concerned, is getting a string. What string? The string returned by join. What string did join return? Well, it's taking all the elements of evens, 10, 12, 16, putting a \n, a new line between them. We get this string back, and when we print it, it happens to have new lines inside of it. Fantastic. So really, by keeping track of our data structures and which types we're using at all times, it really helps us to structure our program. And I can't stress enough, you can really reduce the amount of code you need to use by choosing the correct data structure, by choosing the correct way to align and assemble your data. And we haven't really done much with complex data structures. But you can imagine, let's just say you have a phone book, and that phone book contains names, and you know that you're always going to want to show the phone book last name, comma, first name. So you'll store the names. Let's say it's a list of lists or a list of tuples. Internally, you'll store it with last name and then first name, so that sorting will just work out of the box. You won't need to do anything fancy with the sorting. And so by doing a little bit of work up front and figure out how you're going to use your code and how you're going to use your data, you can sort of define your data structures much better. Any questions about this or other related things before we go to dicts? Okay. Very, very good. So there's so many ways that we can talk about dictionaries. But I think an easy way to start talking about them is to compare them with lists. So I'm going to do this. I'm going to say here my list equals, let's say here, A, B, C, D, E, F, G, H, I, J, K, L. And this is, of course, just a ridiculous list of words or pseudo words. If I want to get the first, I say my list of 0. Second is my list of 1. Third is my list of 2. Okay, so far so good. What if, though, I have information about a person, right? So I can say here, like, person equals, like, shoe size is 46. Fine. So now if I want first name, I'll say person 0. Last name, I'll say person 1. And shoe size, I'll say person 2. Now this will work, but I have to start remembering which is in 0 and which is in 1 and which is in 2. If you have 3 fields, who cares? But if you have 10 fields, 20 fields, 50 fields, 100 fields, there's no way on God's great earth that you're going to remember which number is which. So one way to think of dictionaries is to say, like lists, but we can use either ints or strings as the keys, which are the indexes. Meaning, in a list, or in a tuple, or in a string, we are told what the indexes will be. They will be ints starting at 0, then 1, then 2. We can get an incredible amount of flexibility, though, with dictionaries. So let's do that. I'm going to create a dictionary. I'm going to say here D equals, and now we're going to use curly braces. And the curly braces allow us to define a dictionary. But unlike in a list we know what the indexes are going to be, 0, 1, and 2, because it always starts at 0. With a dictionary, we can use whatever we want. Integers, even floats or strings, and some other things too, but we're going to concentrate on ints and strings. I can choose what the keys are. It's not just going to be 0, 1, 2, which means I have to specify them. So I'm no longer going to be saying, here is the first thing, the second thing, the third thing. I'm going to say, here are my pairs of data, what are known as key value pairs, or sometimes known as name value pairs. And the idea is that I'm no longer going to be putting in individual data. I'm going to be putting in pairs of data. Key, value, key, value, key, value. A key cannot be without a value, and a value cannot be without a key. So how can I redo my person data in a dictionary? I could say here, first, colon, Reuven, and then last, colon, learner. By the way, I'm putting in the extra spaces just to make it a little clearer. And then we say shoe size, colon, 46. And so now if we look at our dictionary, sure enough, it has key, value, key, value, key, value, where the colon separates the key from the value. And the keys can be typically strings, integers, floats. The values can be absolutely, positively anything at all. No restrictions on the values at all. Okay, that's great. So I've stored this. How do I retrieve it? Well, I retrieve from a list with 0, 1, and 2. That's implicit. Here I have to use the key. So I can say D of first. Notice, first is a string. So I have to put quotes around it. D of first, Reuben. D of last, Leonard. D of shoe size. What if I say D of email? Nope, not a key there. Oh, and I have a value can be a list. A value can be literally anything in Python. A value can be an int, a string, a list, a tuple, another dictionary, a file, a module, a function, a class, anything at all. And here's the reason why. When you define a variable in Python, you're not really defining a variable. There are no variables in Python. Rather, when you say x equals 100, you know what you're really doing? You're really assigning a key value pair into a dictionary, where the key is the string x and the value is 100. So literally everything in Python is actually stored in dictionaries. Dictionaries are the most important data structure, bar none, in the entire language. And you can think of the whole language as a whole pile of dictionaries. Every object, a dictionary. Every module, a dictionary. Every namespace, a dictionary. Everything's a dictionary. So we can use these dictionaries for our own uses as well. But that explains how we have that flexibility there. So if I want to create a dictionary and assign key value pairs and have it sort of be a database, as it were, that sticks around that I can retrieve from, yeah, I can totally do this. Now notice a few things about this. I'm still using square brackets to retrieve. Weird, I know, but use square brackets to retrieve from strings, from lists, from tuples, and also from dictionaries. No way around that. Second thing is my key here, it must exist, right? I asked for the key email, doesn't exist, so I get a key error. Just as if you ask for something, if I say like, hey, what's my list of 999? It's gonna say, hey, that's an index error. That is like, that index does not exist. The difference is that the list determines what my maximum index will be, whereas I determine what keys will be available in my dictionary. The dictionary can have any number of key value pairs that you want, absolutely positively. And so if I say here, okay, here's D, what's the len of D? Remember, we can run len on a string and get the number of characters, len on a list or a tuple, get the number of elements. What's the len of D going to be? And the len of D is going to be 3. Why 3? Because 3 pairs. Dictionaries do not think in terms of elements. They think in terms of pairs. Again, every key has a value, every value has a key. Seems like dictionaries are like JavaScript objects, so you don't give them an object name. Yes, so, okay, so first of all, everything, absolutely everything in Python is an object. For those of you who know something about object-oriented programming, it basically is a way to standardize how things work. So everything in Python is an object. You could argue then that that's why everything in Python is a dictionary, because dictionary is an object. JavaScript uses the word object in some weird ways. But effectively, you could say that dictionaries are like JavaScript objects, yes. And I mean, I could, oh, JavaScript. Anyway, where do I begin? Where do I end? Luckily, I'm in Python nowadays. So let's say I want to search inside of my dictionary. We know that I can search inside of a string within, right? A in AIOU, that's going to return true or false. And 10 in 10, 20, 30 is going to return true or false. So what if I want to search in my dictionary? What if I say, hey, is Reuven in my dictionary? No. Why not? Because, oops, searching in dicts happens on the keys only. So I can say first in D, and the answer is true. So you could only search on the keys. I mean, there is a way to search on the values, but it's really inefficient and not a good idea in general. If you're searching on the values on a regular basis, you're probably doing something wrong. So I can retrieve from a dictionary. I can search inside of a dictionary. What else can I do in a dictionary? Well, that actually, just that functionality already gives us an incredible amount of power. And these key value pairs, when you first start using them, you're like, okay, key value pairs, whatever, it's not that exciting. I'm telling you, I mean, I don't know if it's exciting, right? It's exciting for nerds, but not exciting necessarily for normal humans. But I'm telling you that this is incredibly useful. Dictionaries can be for computer names and IP addresses, for usernames and ID numbers, for usernames and passwords. But remember, the value in a dictionary can be anything, a list, say. So you can have the user ID and all their fields for their information. Or you can have a user ID and a dictionary describing the user. You can have a file name and all the metadata about that file. You can, like, the moment that you start seeing the possibilities, they become infinite, because dictionaries really are incredibly, incredibly powerful, and yet they're so simple to work with. We use them for all sorts of things all the time in Python. So I can create a dictionary, I can retrieve from a dictionary, I can search in a dictionary. What if I want to change a dictionary? So can I do that? The answer, of course, is yes. I should say, of course. Dictionaries are mutable. They can be changed. So I can see here, and say here, D equals, there's an empty dict. And then I can add to it. So I can say D of A equals 100, right? So I've added the key value pair, A, 100. All right, so far so good. And if we check, what's my dictionary? Yeah, A, 100, very good. I can now add D of B equals 200. And sure enough, we've now added D of B. What if I now say D of A equals 999? What's going to happen? And the answer is we have now replaced the value that was previously associated with A, right? So we replace the value, but the dict, associated with A. Meaning, the first time you assign a key value pair to a dictionary, that key gets a value. That key value pair is created. The second time, you simply replace the value. So it's not like a list, in that in a list, if you want to add something, you use append. In a dictionary, that's not how it works at all. In a dictionary, you don't append to add to it. You just assign. And the dictionary knows, oh, this is new, or oh, this is not new. And so you can really use the dictionary to store all sorts of different things. You can imagine keeping track of how many times users have logged into your system. Imagine keeping track of, right? Imagine, let's say you want to do a really, really, really simple version of like Google Maps that like keeps track of all the places you've gone. So you could have a dictionary in which the user IDs are the keys, and the values are going to be lists of all the coordinates where the people have been. And then you want to find out where they've been, you just do a for loop over all those coordinates. You can retrace their steps. I've not exactly looked at the code. Can you add another way? Sort of. There are a few other ways to add to a dictionary, but they're a little more esoteric. You can like add conditionally, you can merge dictionaries, but overall, assigning to a dictionary is the main way to do it. And so we can already think of, based on the example that I've given, two basic ways. Oh, can you add another key? Yeah. Oh, I'm sorry. Oh, I misread it. And like, you can add as many keys as you want. You can have whatever you want. So D of X equals 1, 2, 3, and D of Q equals 4, 5, 6. Yeah, absolutely. And the values don't have to be of the same type either. So D of R equals 10, 20, 30. And so as far as Python's concerned, the dictionary here contains 1, 2, 3, 4, 5 key value pairs. And the values are int, and list. Totally fine. Nothing wrong with that. Python's totally happy with that. Other questions about this so far? Okay. Let's try this. I'm gonna give you an example of sort of the kind of thing that we can do with our dictionaries. So I'm going to create a really, really, really small dictionary now, really small, like 3 or 4 entries here, of country names and country codes for like for telephones. Remember telephones before? Anyway, so I can say here, let's call it phone. I guess so. Dial codes. What are they called? Like, I don't know, international prefixes, calling codes, whatever. Country codes equals, and I'll say here like the U.S. is number 1. All right, don't read anything into that, folks. Right, and then we can say here, Israel I know is like 972, and I think like the UK is 44, if I'm not mistaken. And I think China's 86, 84, something. Oh, I'll just leave it at 3. Oh no, I forgot to do, what did I do here? Oh, I forgot a comma. There we go. And so you've got to have, notice I have key, colon, value, key, colon, value, key, colon, value. Oh, can you delete a key? Oh, great question. The answer is yes, but. There is a way to delete it. So I'll show you actually, if I have here like D as my dictionary, I can say D.pop of A. And this removes the key A and returns its value. And we have there 999. And now if we look at our dictionary, it has been removed. Why do I say yes and no though about that? It's pretty unusual in my experience to delete a key from a dictionary, but definitely can happen. Like, there's nothing technically wrong with it. There's another way to do it, but this seems to be the more popular one. So I'm going to create my little country codes table here. And you can see already, like, oh, this key value pairs, they might be able to come in handy. So watch what I'm going to do. I'm going to run a little information service for the internet because no one can look things up on their own. So I'm going to say here, while true, say here, country name equals input, enter country name. And I can say here, if not country name, break, meaning line country name, exit the loop. In all other cases, I'm going to say then I'm going to say here, if country name in country codes, print code for country name is country codes, square brackets, country name. I'm going to explain this in just a moment. Else print no info for country name. Okay, so now I'm going to enter a country name. I'll enter Israel. So what's going to happen now? So the string country name is going, the variable country name is going to refer to the string Israel. So far, so good. If not country name, is the country name blank? It is not. So we get to the next one. If country name in country codes, that's going to search, is Israel a key inside of this dictionary? The answer is yes. So what are we going to do? We're going to say, okay, code for Israel is, and then we're going to do a retrieval here. We're going to say country codes, square brackets, country name. Well, how's that going to work? Well, country codes, that's a dictionary. It knows what to do with square brackets, but it only knows what to do with square brackets if in the square brackets we have an existing key. What's the existing, what's the key going to be here? Israel, the string. So it's going to retrieve it, put in 972, and great stuff. What if I say here, don't take it this wrong way, France says no info for country France. Right? So basically what we have here is a little database that we can use, and we can retrieve information from it. And thanks to the fact that we can use in to search in it, we have this incredible flexibility. I'll just press enter here to exit. So could I have done this with a list? Yeah, but it would have been so much messier. Oh, there's something in QA. Can a dict handle very large numbers of key value pairs, such as long running time series data? The answer is yes. Yes, absolutely can handle large amounts of data. The limit is, like everything in Python, how much memory you have in your computer. So if you want to store, 1 million data points and you have enough memory for that, go for it. If you want to store 1 billion data points and you have memory for that, go for it. I mean, at a certain point, you will run into memory problems. But yeah, dictionaries can, think of, again, Python has thousands of dictionaries, even when it's just like running idle and doing nothing. So it's using lots and lots of dictionaries. And I will add dictionaries improved in Python 3.6 about 2 years ago. When they came out with that version, they reduced its memory footprint by about 1/3, which is tremendous, tremendous. Okay, so you can see here we can use this little dictionary. We can also use dictionaries. I'm sorry, we can use it as a little database. We can also use dictionaries to sort of accumulate information over time. So watch what I'm going to do here. This is similar to what we did before, but I'm going to do a little differently. I'm going to say here, counts equals evens, 0, and odds, 0. So now what am I going to do? Now, this is instead of having my even counter, my odd counter, my even list, my odd list, now I'm just going to put it inside of a dictionary. And it's really convenient to use a dictionary for this. But currently it's 0. What I'm going to do is I'm going to ask the user to enter numbers one at a time. And then I'm going to increment the count in the appropriate dictionary slot. So I'm going to say now, while true, we say here n equals input, enter a number. I can say here if not n, break. So once again, if it's empty, if it's blank, then break. Right? If empty, blank, then break. So now what? Now we're going to check to see if it's actually an interval. We're going to say if not n is digit. Print n is not an integer. Try again. Continue. Okay. Now we're going to check to see if it's even or odd. I can say here if let's say, well, now we have to turn it into an integer. So n equals int of n. Say if n modulo 2 equals 0. Then watch what I'm going to do. I'm going to say here counts of evens plus equal 1, else counts of odds plus equal 1. What am I doing here? I'm saying go to the counts dictionary, find its value associated with the key evens, and add 1 to it. And we're going to get then a running total in our program of what we saw. So if I now say here, right, 10, 11, 12, 14, 16, 18, enter. So if I now look at counts, our dictionary, look at that. It's up to 5 evens and 1 odd. Yeah, that is actually what happened here. So dictionaries are great for little databases. Dictionaries are great for accumulating information over time. They're great for all sorts of things. Someone said a number of years ago, I remember seeing they wrote that Python programmers think that like everything, all problems can be solved with dictionaries. Maybe. Like, to some degree, that is true. It's a little bit of an exaggeration, but less than that person was hoping to be, or maybe they knew what they were talking about. But they're just so incredibly convenient. But I want to take you a little deeper into dictionaries and how they work and what they do and why they're so incredibly special and why we like to use them so much. So here's the thing. Let's say I have a list. My list equals 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Very good. And I want to find out, is 50 in my list? Can we append the number in the dictionary? Oh, so you don't append to a dictionary. You can assign to a dictionary. So this actually just replaces the existing number with our new number. If, however, we would want, we could have a list here. Then we could do append to that list. We could append to the list that's the value associated with that key. So let's say I have my list here. My list is 10 through 100. And I say here, hey, is 50 in my list? How's this going to work? Well, behind the scenes, Python is basically running a for loop. And it's starting at the beginning and going 1 by 1 by 1 until it either hits 50, in which case it stops and says, yes, I found it, we're done. Or it does not hit 50, and it gets to the end, it says, okay, I got to the end, not there. So that means that the amount of time it's going to take for us to search for 50 or for any other value is what we call in the computer science world, in big O notation, O of n. This means the search speed is proportional to the list's length. So the longer, the non-fancy way to say that, I guess, is the longer the list, the longer you'll wait. So what if I create a dictionary, though? And I say D equals, A1, B2, C3, B4, E5. And now I say, hey, is C in D? And the answer is true. Okay, so far so good. How long did this take? So it turns out this is what we call O of 1, constant time. What the heck does that mean? It means no matter how big or small, it'll take the same time to find something in D. That is mind-blowing. That is why we use dictionaries for variables in Python. That is why we like to use our key value pairs. And by the way, it's not just for searching. It also means when I say, hey, D of C, the first thing that Python has to do is say, is C even a key in D? Meaning it has to search, meaning every single dictionary lookup takes this long, meaning every single variable lookup takes this long, or as it were, doesn't take that long. Well, here's my question. How the heck did they do that? Right? Like, it makes sense. It's sort of intuitively clear how I can end up with O of n for searching the list. 1 by 1 by 1 by 1 by 1, go through it. But how can it be that it's constant time? This is thanks to some magic known as, oops, not there. This is thanks to some magic known as a hash function. And we're not going to get into the specifics of hash functions and so forth, and I don't even understand Python's hash function at the lowest level. Like, I've got some basic understanding of how it works, but they're hard to understand and sort of on purpose in many ways. Hash functions are used in a whole lot of different places, including in web browsers and on the internet for encrypted communication, but that's not being used here for encryption whatsoever. So I'm going to give you 2 analogies here so you'll understand how it's working with our list and our dictionary and the genius of how dictionaries were designed. By the way, dictionaries exist in other languages as well. So in other languages, dictionaries are called all sorts of things. They're called hash tables and hashes and associative arrays and maps and hash maps. And even, as someone mentioned earlier, Larry mentioned earlier about JavaScript, JavaScript, right? Objects. So it's basically the same idea. Of course, there are nuances, there's slight differences, but overall, that's how it works in these different languages. So what the heck is this hash function doing? So I want you to imagine a world in which we actually go to visit people at their offices. I know, crazy talk, but stick with me here, science fiction. So you go to an office and you know that your friend works there, but this is kind of like a cheap office. And so there's no sign on the door, there's no directory, and there's certainly no receptionist to tell you where to go. How are you going to find your friend? Well, you're going to go, and you don't know what office your friend is in. Some friend. So you're going to go from office to office. Is my friend here? No. Is my friend here? No. Is my friend here? No. Is my friend here? Yes. Bam. Oh, why weren't you earlier? Because I had to look for your office. Okay. That is how searching works in a list. And you can imagine then why it's going to take O of n. It's going to be proportional to the, like imagine going to visit your friend at a 10,000 office building as opposed to a 3 office building. It will take longer because you will on average need to search for more time. So a dictionary works very differently. Let's say your friend's name is John Smith. Okay, so you get to the dictionary building to visit your friend. And the dictionary building is also kind of like run down, no directory and no receptionist, but there is a sign. And the sign says, if you want to find someone, go to the office with the number corresponding to their last name. And that is A is 1, and B is 2, and C is 3, and so on and so forth. And so John Smith, S is going to be, I believe it's 19. So I go to office 19. I ignore offices 1 through 18. I go straight to office 19, and right there's my friend. Because in this case, I didn't have to search elsewhere. I was able to use the data. I used my friend's name to know where they were going to be located. That's exactly what's happening in Python with a dictionary. When I store the pair A1, Python looks at A and says, I'm going to use you and translate you, the key, into an address in memory so that the next time someone says, hey, is A in D or D of A, I just know I can use A, run the hash function, jump to the right place in memory, and retrieve the data. And if you're thinking, wow, that's not that complicated, yeah, that's part of the beauty and the elegance of this stuff. I mean, people who develop hash functions are really smart, and like that's hard. But using them, it's shockingly easy. And it just like happens all the time. This is why people love to use dictionaries, because they have very fast searching, very fast lookup time, we would say. They don't take up that much memory, actually, and you can store anything you want in them. Amazing, amazing, right? Questions or comments until here, and then we'll do a little like mini exercise and talk a little more about other stuff we do with dictionaries. I'm just gonna drink a little more, so I will give you also more time to ask a question if anyone has. Okay, so, oh, and I just realized I was not reading the questions out loud during the recording. I've been asked to do that, I'm sorry. So it reminds me of a database key search, Krishnendu says. Yes, indeed, yes, indeed. In fact, if you use a database, I mean, I'm a big PostgreSQL fan, but MySQL, Oracle, anything. They use different kinds of indexes, and one of the kinds of indexes you can use is a hash index. That's exactly what's happening here. And that's why, by the way, right, an index in a dictionary, I'm sorry, an index in a database is often known as a key or a primary key. Guess what we're calling these? Keys, keys and values. Excuse me. The other thing is, you might know that like there are different kinds of databases out there. One kind of database that's kind of popular nowadays is known as a key value store. Guess what a key value store is? It's basically a dictionary that you can access over the network. Now, these ideas have been around for about 60 years. It's pretty amazing. It's not a new set of ideas. They do keep getting better. As I said, like just 2 years ago or so, Python improved its version of dictionaries, which I was quite shocked by, actually. because I figured, oh, like what more is there to do? But no, dictionaries actually work pretty well. Okay, so we can use dictionaries then for a little database. We can use dictionaries for accumulation, and we can use dictionaries just to like store store information during a program. We can build up a dictionary from nothing. So here what I said was, for example, I'm going to start with my dictionary, evens and odds. What if I start with an empty dictionary? So here's what I'm going to do. I'm going to say here, counts is an empty dictionary. Then I'm going to say s equals input, enter a string. And then I'm going to say here, for one character in s, and I'm going to count how many times each character appears. How am I going to count it? In counts. Now, what I would love to do is say counts of one character plus equal 1. There's only one problem with that, which is it won't work. Why won't it work? Because counts one character plus equal 1 says add 1 to the value that's already there. Oh, wait, but there's no value there yet. So the first time we're going to like bomb. So what I have to do is say, well, is there already a value there? If so, add to it. If not, just stick the key value pair in there. It'll look like this. I'll say here, if one character in counts. Now we're searching. Then I'll say counts one character plus equal 1. Otherwise, I'll say counts of one character equal 1. Notice the difference between these two very similar lines. Here I'm saying, oh, we already have one character in counts, so I will add 1 to it. Here I'm saying, I don't have one character in counts, so I'm just going to set it to be 1. And then I can say here, print counts. So watch this. I can say this is a test. It's going to say T appears 3 times, H appears once, I appears twice, S appears 3 times, space appears 3 times, A once, and E once. Pretty amazing. Pretty amazing, huh? It's like so easy. So you can imagine going through a file system. You have a directory name. You go through all the files in a file system and you say, how many exe files do I have? How many DAT files do I have? How many PDF files do I have? You can accumulate and keep track of so many things in a dictionary. It's like, it's just so easy. And it fits into our for loops from before, plus equal from before. Like all the things that we've been doing until now, I don't want to say they've all been leading to this very moment, right? It seems a little too intense. But they show that the way that Python works is extremely consistent and useful and builds on itself. There is one thing, though, that's kind of annoying here, at least one thing, which is I print out counts and I print out the dictionary, and that's what I get. Come on, there's got to be a better way to print this out, right? Well, how can I go through a list one element at a time? For loop. How can I go through a string one element at a time? For loop. So guess I can go through a dictionary one element at a time? For loop. Good guess, good guess. So I'm going to say here for one item in counts. Counts is my dictionary, right? Print one item. And what are we going to get? The keys. So here's the thing. If you iterate over a dictionary, you get the keys. Yeah, but I don't want just the keys. I want to get the keys and the values. So you have 2 options. One option is to retrieve. How do you retrieve? With a square brackets. For one item in counts is a print. Actually, I just call it key. Key, colon, and then I'm going to say here, counts key. Notice what I have here. Inside this, it's a little confusing. I've got curly braces here. That means evaluate this code. Counts key means go to the counts dictionary, retrieve the value associated with the key. And sure enough, now we have our little table here. By the way, I didn't mention it before, but perhaps, I guess these things, I think of them as obvious, but just in case, every key in a dictionary is unique. A key cannot exist more than once. So when I say counts of one character equals 1, we are overriding the previous value. It's in its place. So you can see here we're going over counts. We're getting each of the keys. We're saying, hey, what's the value associated with this key? And sure enough, we're printing it out. Notice also that dictionaries, this is a modern thing in Python 3.6 and better. The dictionary keeps track of the order in which we added the key value pairs. So we were writing this is a T, E. You can see that basically it previously had the T and so forth. But this is the order in which we enter the characters. But truth be told, this is a little annoying. A little annoying, to me at least, to iterate over the dictionary and get the keys alone. I typically prefer to use something called items, the items method on a dictionary. So I can say for one thing in counts.items. And look what I'm going to get. Print one thing. I'm going to get a tuple. That's right. Items, oops, the items method returns a tuple of key value pairs, or I should say like a key value tuple with each iteration. This is amazing. And it's even more amazing when you see how we can grab it. For key value in counts items. Print key :value. What the heck? Well, counts.items with each iteration is returning two things. It's returning a key and a value. I could stick that into a tuple and grab thing 0 and thing 1. But instead what I'm going to do is I'm going to grab them using what we call tuple unpacking. This goes to key, this goes to value, and then I have the two variables defined, then I can use them. Now the output looks precisely the same as before, but the code is, in my opinion, easier to read, more understandable, and so forth. Questions or comments about this so far? And I hope you're amazed by this. Dictionaries are just incredible. Questions, thoughts, comments? All right, let me show you. We'll do like a micro exercise. I know that people often don't have time to do it, but I want you to at least like think about the the implications. Oh, great. Dory asks, can you sort the dictionary? So change the order things were entered. The answer, you know the answer, yes and no. So you cannot change the order of items in a dictionary. Part of the way a dictionary works is it needs the order to be in its order in order to be able to work with it. But what we can do is we can sort, we have two options. One is we can just use the sorted function and get the dictionary back in order that we would want. So for example, if I say here, sorted of counts, look what I get back. Whenever you do an iteration, a for loop on a dictionary, you get the keys back, right? So I'm gonna get the keys back in sorted order. This is like increasing ASCII value from lowest to highest. So that's one way to do it. That's how we usually do it. If I want to sort a dictionary somehow, like if I have names and values, then I'll do it. Another way to do it, if you really want to be permanent, is you can pop things out and assign them back in, because the dictionary remembers it in chronological order. Okay, so let's try this. I'm going to say now, I'm going to tell you what I want to do. I'm going to give you like 2-3 minutes to think about it. I don't expect you to be able to code it up in this time, but at least like get the thinking going, and then I'll show you who can do it. So what I'm going to do is ask the user to enter a sentence, words, whatever. All right, we're going to then count how many numbers, let's call them digits, vowels, and see other characters are in the user's input. Keep track of them in a dict, and then print each count when we're done. Now this is similar to what we saw before, but now we've got a few more things we're checking. Okay, so I'm going to give you like 2-3 minutes to think about this. If you have questions, please don't hesitate to put them in the chat, and then we will go over this, and then I'll tell you 1 or 2 more dictionary things, and I think we'll close up for the day. So Roy says he likes the PyCon Cleveland shirt because he's from Cleveland. I'll tell you, I was at PyCon twice, both in Cleveland. This is from the first one I was at, so I guess like 2 years ago. The shirt from last year, not nearly as good, but I have 2 of them. And it turns out like I got a bunch of shirts. One for my second child, my second daughter is into programming Python, so I brought her a PyCon shirt back from each of the conferences also. And we woke up today to discover that both of us have worn our PyCon 2018 shirts. So we're twinsies. But actually, it was a great conference, and it's a crying shame that we weren't able to have it in Pittsburgh this year. But such is life. By the way, I should add. I'll send it out in the email, or I'll put it here. If you want, like my talk from PyCon is up online. Let me just grab the URL actually, in case you didn't get a chance to see it. It's a little advanced, but I had fun. I had fun giving it. So you should have fun watching it. What I call it? I call it the function dissection lab. That's right. And we haven't done functions yet. Some of it might seem a little weird. But if you go to, you can actually just go to functiondissectionlab.com. I bought that domain for this talk so that people could, I guess I can put it in the chat. I forgot I can do that. And then you can also, if you want to download the slides as well, send chat to everyone. There we go. Bam. Oh, I guess I could just make that a URL. Anyway, if you go there, hopefully you can enjoy, learn some things. And there was actually one guy, Dustin Ingram. Dustin Ingram is like, I think he works for Google. So he gave a talk, and because we all had to record it on video. So every time you see him, he's wearing a different PyCon shirt. He must have worn like 50 of them for the talk. It was amazing. All right, chat asks, can a value in a key value pair be another key value? Yes, sort of. It can be another dictionary. So you can have a dictionary whose values are dictionaries, and you can go as deep as you want. In other languages, we would call that a tree structure, and trees are extraordinarily common. So basically, trees are used in XML and HTML and network analysis and all sorts of other stuff. So basically, yeah, like it's amazing. Oh, and Krishnendu says, I'm trying to go through your book. How can I ask you questions on them? So you can email me if you want. I believe actually Manny has a website there with a forum, and I think I should be checking it now that I think about that. I haven't checked it in a while. So if you're, I guess you must be reading the online version of the book because it hasn't been printed yet. Soon it should be printed. But if you go to the website, I think asking questions there in the forum is probably the best thing. And if it's something that's not clear to you, they're going to be giving me the final typeset version to edit within the coming days, like 2, 3, 4 days, or so they've been saying for a month. So if there's something not clear, now's the time for me to clarify it. I would greatly appreciate that feedback. But I'm pleased that you bought the book, and I hope you're really enjoying it a lot. Okay, let's go through this micro exercise here. Micro, I know you're thinking, oh, it's not so micro. Okay, so here's what we're going to do. We are going to say here, ask the user to enter sentence. So S equals input, enter a sentence. What we want to do is keep track of how many digits, how many vowels, and other characters are there. So what I'm going to do is I'm going to say here, right, count. I'm just going to call it counts. I'm going to say here digits, colon 0, and vowels, colon 0, and other, colon 0. And remember that a dictionary, right, we can start it empty, but we can also start it preloaded with the things we know. And it's a question of, am I going to be accumulating things I don't know over time or accumulating things I do know over time? And here we do know what we're looking for. So now what? So now I'm going to go through each of the characters there. So for one character in S, I'm going to ask a few questions of it. I'm going to say here, hey, right, if one character is digit, then we'll say counts of digits plus equal 1. And then elif one character in AIOU counts of vowels plus equal 1. And finally, else we can just say counts of other plus equal 1. And so if I run this now, oh wait, I wanted to also then print out the counts. So then we can say here, for key value in counts items. And you can use anything instead of key value. You don't need to do that, but it's kind of, I do it a lot. So print key colon value. So let's run this. Now I can say this is a test, you know, or this is test number 3 for my program. Bam. And it's going to say there is 1 digit, 8 vowels, and 27 others. And again, counting the types of characters you have, that's like not something people do seriously. I mean, I'm not against it, right? But you can imagine going through a bunch of users on your system and pulling up the information and then sorting them by administrators, non-administrators, you know, people who have, you know, IP addresses that are suspicious, not suspicious. You can easily use events all using dictionaries. By the way, do we need a dictionary here? Couldn't I just use 3 regular old variables? Yeah, I could. But then it is so much easier to print this sort of report out. It just makes life much easier to work with. All right. Dictionaries are super, super useful. And it's a rare developer who, especially in Python, who doesn't use them all the time. Again, like we just sort of think in dictionaries. And Python itself, the language itself, uses them all over. So, all right, we're going to finish up here. I will put some homework in the forum, but I want you to understand the dictionaries. We've now gone through all the major data structures in Python. That's it. You've got none, Booleans, true and false, integers, floats, strings, lists, tuples, and dictionaries. Are there other data types? Yes, there are, but they're all based on the ones we've discussed so far. So for example, there's something called a default dict, a dictionary that if the key does not exist, you won't get an error, it'll have a default value, right? All sorts of little things that are built on these. But understanding these, this is where it's at. And then we can start building on top of it. And indeed, I would say, starting next week, we're going to start talking about files, how we can read from files and write to files, and how we can read from a file and turn it into a list or a string or a dictionary. And we can take a list or string or dictionary and turn it back into a file. Now, these are going to be plain text files. So don't get any fancy ideas about like PDFs and Excels and PowerPoints. But it's the same ideas, just at a lower level. Will we cover functions? Yes. My plan is next time to talk about files. In 2 weeks, we'll have to take the week off because there's a big holiday here in Israel. And so in 3 weeks then, so we'll have talked about files. We're then going to talk about functions for 1 or 2 weeks. We're going to talk about modules. And I think that's where we're going to end it. It'll probably be about like 12, 13, 14 sessions in the end, something like that. That is my basic plan for this course. But we're definitely going to talk about functions, probably for 2 sessions, because functions are so incredibly important. And I was thinking earlier today that when we finish covering everything, we'll have one final session, just like open Q&A. So if people have things they're confused about, people want to know about other topics in Python or computer science, we can do that. Any other questions, folks? Anything I can help you with? All right. Thank you so much for joining me once again. The video will be up. The exercise will be up probably on Sunday. And I greatly appreciate you coming. Have a fantastic weekend. Stay safe. Don't get too hot. Stay indoors. And I will see you all next week. My great pleasure. Bye, folks.